I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Manipulating light with sound is not a new concept. In fact, technology facilitating it has been around for years. But a new device could change the game. Scientists at Stanford University have developed a nanodevice they say is a new type of acousto-optic modulator that can manipulate light that's typically limited to gaps just a few nanometers across, allowing more precise control than is possible with conventional systems. The new approach involves 100 nanometer gold nanoparticles atop a gold mirror and separated by a layer, anywhere between 2 and 10 nanometers thick, of polydimethylsiloxane, a silicon-based organic polymer. The team says surface acoustic waves launched by an interdigitated transducer on a lithium niobate chip oscillate the mirror surface at an amplitude of around 0.3 nanometers. Those waves also periodically squeeze or relax the nanoscale gap. Since gap plasmons are sensitive to angstrom level changes, each particle's optical resonance shifts, in turn producing large, fast color and brightness modulations. This light modulation happens at near gigahertz frequencies, which has proven faster than even the fastest existing spatial light modulators. The team says their work paves the way for ultra-thin, high-speed, low-power optical components that can be integrated like electronic transistors in photonic circuits, displays, or other optical systems. Coherent is now expanding its partnership with Apple with a new multi-year agreement that will extend production of VCSELs, vertical cavity surface-emitting lasers, used in Apple devices for features including face recognition. The technology is built at the Coherent manufacturing facility in Texas. Representatives say the partnership is tied to Apple's American Manufacturing Program, which helps facilitate the creation of new jobs and keep manufacturing of such technology in the U.S. Addressing what Barcelona-based scientists call a critical need in semiconductor manufacturing and nanofabrication, Photonics Research Center ICFO has created Shinephi, a new spinoff focused on advanced interferometric imaging technology. The company will offer advanced optical metrology and make it accessible to companies and laboratories working in the materials science and semiconductor realms. Representatives say this will help others take charge of their own fabrication processes and move beyond the limitations of current standards. Engineers in Colorado have for the first time created extreme electromagnetic fields in a lab. This groundbreaking feat could potentially shrink the massive colliders conventionally used in advanced experiments down to a chip. A new approach designed by a team at the University of Colorado, Denver uses a silicon-based material they've developed. It can endure high-energy particle beams and allows access to the extreme electromagnetic fields created by quantum electron gas oscillations or vibrations. Such fields can be used to build machines for fundamental physics. The new material also manages the heat flow generated by those oscillations while keeping the sample intact and stable via relativistic ballistic transport, an emergent phenomenon underlying extreme plasmons. The process essentially prompts collisionless heat dissipation and preserves the material's structure. The team says that expanding the accessible electromagnetic fields will ultimately advance initial tests of string theoretical predictions. Among next steps in the work is the development of extreme plasmon-based particle accelerator technology to further study things like dark matter and dark energy. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. Check out our Following the Photons podcast, too, for some cool interviews and news impacting the industry. Until next time.